right, let's go back to our lesson. All right, we're going to be covering 4.08 as much as we can, and everything in the entirety, including the notes. If you prefer the video, is going to be in the ICANN. Come to Help Lab on Tuesday, Wednesday, or Thursday, but you should have done quiz 4.08 by midnight last night. I know there are some people probably in here going, I didn't do it, I wasn't ready. We can't not be ready. We've got to take that first attempt because our semester is ending soon. Don't forget about our best resources that we have to support you. So today we're going to be solving exponential and logarithmic equations to solve real-world problems involving logarithms. So there are going to be a lot of words here. If you've been working on vocabulary and building on that, it may be a little easier for you, but I need your help. So let's go back to what we were talking about a minute ago. Recall the one-to-one property of exponents. If we have the same base and we have different exponents, can you tell me what that means? What does that mean to you? What does b to the x equal b to the y mean? Any ideas? What that means is, yes, very good, x equals y. So the exponents have to be equal. Let me show you an example. And also write this down because we're going to have this or something like it in our exit ticket on the first question. So as you said, x equals to y. So let me put this, replace the base with the number, a simple number like the number 2. So can you readily see that x has to equal 2 for that to be equal? Now let's extend that to the one-to-one property of logarithms. I need you to write this down. Log b x equals log b y gives us the same kind of equation that we can set up. Now these two statements will be equal. So I want you to copy this down and keep it in your notes because we're going to have that as the first question on our exit ticket. And we're going to be using this throughout the lesson. So let's set up an example. Okay. Let's put the example log base 2 of x. So let's replace b with the number 2. And let's replace the x with an expression, 2 of x. And then equals log base, we have to have the same base for this to work, 2 x plus 7. All right, what's the equation that I can set up using the property of logarithms? Either on the mic or in the chat, type out the equation I can set up. So we basically cross this out, and what's the equation that's left? Addison, are you with us? Looks like some of you may have walked away. Elijah, look at the board. Tell me what equation we can set up. Put it in the chat. Chris? Azul? There we go. 2x equals x plus 7. So if I subtract x from both sides, then I have 2x minus 1x is x. And then subtract x from this side, x is equal to 7. That's how the property of logarithms helps us. Any questions there? Come on, come on. Let's be engaged here. Don't make me do this by myself. All right, use the property of logarithms to solve this equation. All right, now your turn. Get your paper and your pencil out. Try to beat me to the solution. And we need to look at this carefully. But the first thing that we're going to do, the property of log says I can just disregard log base 3. We have the same thing, log base 3 on both sides. So take that out, set up your equation, and work on solving it. Yes, thank you, Sophia. All right, the first thing I'm going to do, this looks like a trinomial. I'm going to move everything to one side. So I'm going to subtract x and subtract 2 from both sides. I'll line everything up over here to make it easy and save board space. X minus x is 0. 2 minus 2 is 0, so I have 0 here. And on the right-hand side, I have x squared plus, what's 4x minus x? That's 3x. And then a negative 2 and another negative 2 is negative 4. So now you should be able to see from your strong algebra skills, we have a trinomial that we can factor. So you can use a T-chart or you can use Math Papa, because we do not have an exponent in front of the x squared. It's not negative. There's nothing weird there. I just need two factors that multiply to give me a negative 4 and add to give me a positive 3. And those factors are positive 4. So I have two binomials, x plus 4 times x minus 1 equals 0. Okay, very good, Chris. So x, we have two solutions here. X would equal to 1. What's the other solution? Anybody? X is equal to negative 4. Thank you, Sophia. All right, now here's the part that's tricky, but it's not tricky. So just please listen to me. With logarithms, I know this is a different notation, so don't get trapped into the notation. You don't have to go and put this back in exponential form. Just listen to me. We know that when we take a number of, we take a square root of a negative number, we have to toss those out. So anytime you get, for logarithms, a negative answer, it's extraneous. Toss it out. So the only solution we have here is x equals 1. That's true. It needs to be tossed. That's true. You got it. You got it. Y'all are amazing. So guys, because my mouse is not working really good today, it's spotty, it worried me. I have all my work shown on these slides. You're going to download them. Okay? All right, now I want you to pull in, take a minute. I want you to solve this equation. So the first thing you're going to do is you're going to look at and see if we have the same log base. Both of these are log base 3. Set up your equation and solve. You've got 2 minutes. And the timer is running. Do it like we did the last problem. We want to get 0 on one side. So I'm going to subtract x and add 1 to both sides. Give you some time to work on that. All right, over on this side, we've got 0. I'm going to go ahead and flip it around. Put 0 over on this side. And on this side, we have x squared minus 2x. And then negative 9 plus 1 is negative 8. So again, we want to factor that. What are the two factors of negative 8 that multiply to give you negative 8, but add to give you negative 2? I think that's going to be a negative 4 and a positive 2. So put that into these two binomial factors, x minus 4, what's happening to my voice? And x plus 2 equals 0. All right, you have 12 seconds. I've got it factored for you. Find the only answer that's not extraneous and put it in. So we'll have two solutions. We'll have x equals 4 because we're down. There's our timer going off. Put this in if you don't have an answer. It's okay to say that you're still thinking. I know this goes fast. And x equals negative 2. So we've got to toss this out, and the only solution is C. All right. All right, there's the work that I've, yay, yay. All right, let's do this again. Pull in. I'm going to let you start working. Turn on the poll and turn on our 2 minutes. Let you ask questions and I'll assist you. And you can help each other in the chat. All right, so we do have log base 2, and we're going to set up this equation. X. Ooh, I can't do that yet. Ooh, you know what I'm seeing? There's a step that I missed. So let me turn my timer off. Let me pause it. All right, our property of logarithms. This is where it gets sticky. Addition is multiplication. So we can't cross this out until we combine these two like this. This is going to be x times 2x plus 3 equals 1. Property of logarithms. Just like when you have exponents and you're multiplying them, you add the exponents. Okay, for example, 2 to the x, or 2 to the 5th times 2 to the 3rd is 2 to the 8th. Okay, when you're adding logs, we combine them by multiplying. All right, so this simplifies to 2x squared plus 3x equals 1. All right, I'm going to resume my timer. Now, where do I go from here? Do I have anything else? Subtract 1. All right, so let's do the best we can with the amount of time that we have, and I'll come back and answer if I need to. All right, then you can factor. So what does that factor into? But you're guessing right. It's an intelligent guess. So thank you for guessing. All right, let's see how much time we have. We have 20 seconds left. So you are on the right track. Let's see if anybody can come up with the right answer. If y'all didn't get into the course yesterday, this is going to be a little bit harder, but it does take a little bit of practice. Just remember when we have the same log base and we're adding, okay, we don't have to use a calculator, but maybe you got the right answer. Let's take a look at how to solve that. All right, so most of you answered B. Let's see if you're correct. Just because most of you answered it doesn't mean that you're correct. But let's see. All right, so we're going to take that log base 2 out. We're going to take the x and distribute it. We get 2x squared plus 3x equals 1. Now here's the tricky part. It is C. All right, so we've got to keep that log base 2 until we combine these with multiplication. Okay, but then I have to look at this, because how do I bring this over? All right, we have a base 2, and anything raised to the 0 power is 1. X to the 0 power is 1. Anything raised to the 0 power is 1. So log, we've got to write this as a log. We have a log on the left. We've got to write a log on the right. So 1 is equal to log 2 how do I write this? Anybody? Are y'all waiting for me to answer? Log base 2 to the 1 equal 0. Don't really know. Okay, here's where I'm going to ask you to, because I don't have a lot of room here. I've worked it out. is to go into the ICANN, and I'll have the recording with the steps, step by step. Okay? But this is using the property of logarithms. We got started going in the right direction. So here's the solution for your notes. Okay? We took the same log base b, means that we can multiply those expressions. This is what we did right here. We applied the distributive property and we got this. Okay, 2 to the first power is equal to 2x squared plus 3x. 2x squared plus 3x minus 2 equals 0. That's what we factored. And then we have two solutions, but we have to toss the negative solution. Again, I'll have all of that explicitly in the notes. Everything will be in the ICANN later this afternoon. Let's pull in. And this is going to be a little harder if you haven't practiced the properties of logs. So just go through this week and practice. All right, we want to solve this equation. I'm going to go ahead and turn the timer on. Give you 2 minutes. Now this time we're subtracting. All right, Libba, we have a lot to cover, so go into the ICANN, and then after you watch the steps in the ICANN later this afternoon, come into Help Lab if you still have a question, okay? Because working out each of these is going to take a lot of, I could take all period just doing one question. I want you to see a lot of examples. All right, are y'all stuck there? Do y'all need any help? It's dark in here. I can't see. Let me put my light on. Maybe too bright for y'all, but all right, so we've got log base x minus 6. We're going to put these logs on the same side. So let me add log base 3 x minus 6 plus log base 3 x equals 3. That's okay. And this is new. Now what can I do with that? Remember, addition is multiplication. So I can multiply and combine this as log base 3 x times x minus 6. And I only have 3 left on the right. Timer's up, so put in D if you don't know. Everybody needs to be answering. Still a lot of you. If you don't answer, I won't know that I need to help you, okay? So that's only half of you. Where are the rest of you? All right, if I don't need to help you, okay, guys, answer. The poll's up there. Oh, well, good, good, good. Maybe you can help. Where do I go from here? All right, am I going in the right direction? All right, so log base 3 equals 3. What that means is 3 to the third power equals 27. All right, so this could be rewritten as 3 to the third power in log base 3. So we have x squared minus 6x equals 27. Subtract 27 from both sides and you get x squared minus 6x minus 27 equals 0. Factor, and you get 2 factors and 2 solutions, 9 and negative 3. I'm just running through this quickly, but everything will be in the ICANN. All right, so we have to toss out that negative 3, and B is the only solution. So if you were trying to guess a logarithm, you toss that off right off the bat, okay? All right, there's the work. It's going to make more sense when you practice. Now let's get into some of the real world problems. And these come with formulas, and the formulas are in Quizlet and they're in the content. All right, now it's really important that you look at how they're answered, because you can eliminate some questions. And this gets real sticky because the computer grades these types of questions and it's real picky. So take your time on these. First of all, what's the formula for compound interest? Does anybody know? Yep, we need to start with the formula. Okay, you got it written down? All right, the formula that we need, if you can type it in the chat, can save some room. Don't have a lot of room up here. All right, the formula is P principal times 1 plus rate over the number of times the interest is compounded in a period, that's what n is, raised to the n times t. Well, what do all those things mean? All right, A is equal to, there's our formula. A is the amount that's accrued at the end. So this is equal to A. P is equal to the principal. That's what we start off with. Okay, so let's identify that. What is R? What's the rate? 1.4%. Let's write that as a decimal. Move the decimal 2 places. Very good. To the left, 0.014. Okay, what else do we need? N is the number of times it's compounded. Well, it's compounded monthly, and our time is annually. So how many months do we have in a year? N is equal to 12. Now, T is going to be our time. T is going to be the variable that we're looking for. So let's put everything into the formula. So what is A? 8,000 equals 5,000, that's P, times, put 0.14 in your calculator and divide it by 12, because we've got rate over N. 0.14, let me find my calculator, divided by 12. And then we're going to add that to 1. And I'm going to round that off to 1.011. And then I have 1, 2, 3, 4, 5 sixes. I'm going to round it off somewhere to a 7. And then that's raised to the N 12 times T. T is our variable. Now we need to turn this into a logarithm. We have to turn this into a logarithm to be able to solve. All right, so I'm running out of room, guys, but I do have this in my notes. Let me see if I have it on the next slide. Yeah, I have it on the next slide. So when we have it here, we're going to have to take the log of both sides. And then we get 33.6 years. I did 0.014 right here. So that's going to take some practice in using your calculator and finding that log button. So this is the week that you can just drop into Help Lab if you've got questions over this, okay? All right, same thing here. I have an example. of a sample that contains 21 grams of radioactive isotope. After 45 days, 17.3 grams remain in the sample. So the radioactivity is decreasing. It's a decay problem. So we want to know, what is the half-life of an isotope? So this is where it can get sticky if you don't have enough practice. So look at my help in the ICANN, come into the help lab and ask questions. Here's the formula that we're going to use. A sub O is the sample. This is the rate and the constant. When you plug it all in, and I know this is messy, guys, but be patient and all of this will be worked out in the video in ICANN. And then when you take the log, the natural log, then you'll get 161 days. Okay, so don't rush through this. Go ahead and take that first quiz if you haven't, and then wait for this video and then take notes. And then you'll have all week to take your second and third attempt. I'm just running through this so that you'll see an example. All right, let me go back, showing all the work. Let me go back to this one. All right, look at this one. Now, we have natural log. What does LN mean? It means line in geometry, but it means the log base E. And what is E equal to? Euler's number. It's a number like pi that repeats 2 point blah, 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 blah. I don't even know exactly. 2.8 something, I think. But it's an important number in science, okay? And it's explained in those videos that I put in the announcements and in the ICANN. So go back and watch those. So this is log base E. It works like any other base, 2, 4, 6, 8, 10, 7, 9, 13, or E, 2.8, blah, blah, blah. All right, so that's all that LN is. It's natural logarithm. It occurs in nature. So it's going to use the same rules. And when we have a 1/2 in front of a logarithm, we can bring it up here as an exponent, which is what I did here. So I'm using the rules. When we have subtraction, we write that as division, and we can cancel out the natural log. And we can set up an expression on the right and on the left. So once we've got this set up with our rules, we have x plus 26 to the 1/2 equals x squared minus 16 over x plus 4. Then we use our algebra skills. Factor, this is a difference of squares on the top, into x plus 4, x minus 4. Cancel out the x plus 4. But now we've got something squared. We've got to take the square root of both sides. So taking the square root of this side cancels that radical. Oh, I'm sorry. We have this to 1/2. That's a radical. We've got to square both sides. Then that radical drops, and we get x plus 26 equals, go ahead and FOIL this out, x squared minus 4x, and another minus 4x is minus 8x, and then 4 times 4 is 16. And then we end up solving this like we did our previous problems, subtracting the x and the 26 from both sides, setting up an equation that we can factor into x minus 10 and x plus 1, and we toss out our negative solution, -1, and we get positive 10 only. In fact, you could toss these two out. All right, I've got another example, Newton's law of cooling. And I'm putting these examples in here because you're going to see them. And what happens at the end of the semester is you start Googling and you start getting Google brain. I don't want you to do that. Okay? I want you to have the formulas, do the best you can, and you'll end up strong if you let me help you. Okay? All right, what Newton's law of cooling, here's the formula. I have an exit ticket, so I'm trying to make sure that we don't run out of time. We have a cup of hot coffee and it'll cool down over time to room temperature. The principle of physics governs this process. And experiments with a covered cup of coffee show that the temperature in degrees in Fahrenheit can be modeled with this equation. F of T equals 110 E, that's Euler's number, to the negative 0.08 T. T is our time factor, plus 75. So because we're raising this, we're trying to find T and it's in the exponent, we have to set up the equation, show you how to do that, and then take the log of both sides. Okay, all of this is written out step by step. To find when the coffee is 140 degrees, we set it up this way. Hot lava, that's true. Yes, I've got my coffee right here, and it's kind of cold. I haven't been sipping on it, and it's gotten cold here, but it's still good. All right, so once we've got it set up like here, like this, and we have E in the equation, we've got to take the natural log, okay? And we've got to use our properties for logarithms. When we're dividing, we need to know what to do with that. All right, so take a look at this, go through the course, take your first quiz if you haven't already, come in for help. Don't make this harder than it is. Okay, so I've walked through this because I knew that there was going to be a lot. I also want to show you compound interest. And we are almost to the point where we don't have much time left. So I'm going to skip through this is what I'm saying. Don't panic because there's a lot in here. I knew there was going to be a lot. But I'm going to have all of this for you with the formulas worked out step by step. Those steps will be there for you to use and to take notes. And then if you download this PowerPoint, it'll have all the steps as well. All right, the next steps for you. Don't get overwhelmed by this because I know that there's a lot in the word problems. We want to finish any of the course material this week for 4.08. Don't try to do it all at once because you're trying to stuff too much in and it won't sink in. You need to practice. Look at the supporting material in the ICANN. The Unit 4 test, it's not going to be due until after we come back from the holidays. Taylor knows the date. I don't have it in front of me. Okay? So we just want to get through Unit 4 and then finalize your notes for Unit 4. I'm not sure if I'm going to let you turn those in for extra credit yet because there's been too much struggle about how to do it. You should be taking notes in your own handwriting on paper. That is how the brain connection makes things stick. Okay? Quizzes. If you don't do well the first time, take steps to do better the second time. That's use my help. Come into Help Lab, use the ICANN, ask questions. Email sometimes spins in a circle because I get a lot of emails. So it's quicker to come in and ask your questions. Then if I can't answer it in 2 or 3 minutes, I'll make a video that you can find in ICANN. So check the ICANN. What did you say about Alice Cooper? Yeah, that kind of gives us some hope. We're halfway through the year. Y'all have worked really hard. Now, I'll put this in the slideshow so that you would have the rules. If you have not gotten into this 4.08 and finished that, these are most of the rules we've been using. I am too. I'm excited about just sleeping in. All right. So here's our exit ticket. This is not you having to know everything. This is, have you been paying attention? And what did you learn? So let me put the exit ticket up there and see if this link, you can just click on it in the chat. This is the hardest part, but this is the last thing that we're going to cover. Then you've got a break. Take some rest and follow my advice. Don't just do assignments and get them done. If you have to take a semester exam, and I don't think we're going to take one, but if we happen to have to take one because your grade is below 75, you want to practice. Oh, Taylor, you inspire me. I'm going to have to do better with that. All right, is the exit ticket working for y'all?